11th one. When mass and velocity are double, the kinetic energy increases by. So already solved this type of problem, but still let us continue solving this. So the only formula for kinetic energy is half mv square. So taking the values k1, I'll take it as half m1 v1 square, and k2, I'll take it as half m2 v2 square. So mass, new mass m2 is equals to 2 times of old mass, and velocity double. So mass is double. Also, new velocity v2 is also double of the old velocity. So the kinetic energy whether increases or remains same, we have to find out. Let us substitute the values, children. So what is the value of k1? Half m v1 square. But what is the value of k2? Half m2 is now 2m1. v2 is now 2v1 whole square. So the value equals to half 2m1 4v1 square, and this k2 is equals to 8 times of half m1 v1 square. What is the value? k2 is equals to half 8 times of half m v1 square, or k2 equals to 8 times of, what is half m v1 square? It's nothing but k1. So k1. So k2 increases 8 times of the old k1. Hence option 3 must be true. k2 is equals to 8 times of k1. Got it? Any doubt, children? So we already solved this method. Second. Yeah. So k1 is half mv1 square, k2 is half m2 v2 square. m2 is double of m1, v2 is double of v1. So substituting all the values in the k2 and substituting, we'll be getting the value of k2 is 8 times of the previous kinetic energy. Okay, so let us move to the next question, children. That is 12th question. A horse and a dog run at the same velocity. Two animals are there. One is horse, the other is dog. They both are running with the same velocity. V is constant. If mass of the horse is 10 times to that of the dog, what is the ratio of the kinetic energy? Children, as usual, the formula for kinetic energy is half mv square. Here, two things are comparable. One is horse, the other is dog. So, let us take for horse as half mass of the horse and velocity of the horse square. K equals to half mv square for h. Similarly, for a dog, half mass of the dog, velocity of the dog square. This is equation 1 and this is equation 2. Before that, what is mass of the horse is 10 times that of the dog, but moving with the same velocity. So, given condition, let us write the given condition. So, given that mass of the horse is equals to mass of the dog, let us keep it as some m. And what else is given? Velocity of the horse equals to velocity of the dog, each same. Horse and dog run with same velocity. Let us keep it as v. But mass of the horse is equals to 10 times that of the mass of the dog. So, wherever you replace mh can be replaced with 10 times of md. Okay. So, comparing the two things. One is kinetic energy of the horse and kinetic energy of the dog. So, let this be equation 1 and this be equation 2. So, let us divide kh upon kd, because first horse is given, second dog is given. So, kh upon kd. Formula is half mh vh square half md vd square. So, kh by kd equals to half mh vh square by half md vd square. Substituting the given values, we have half Instead of mH, I should replace it with 10 md, mass of dog. VH and V both equals to V whole upon again half mass of the dog as md itself into V. Solving the above two, V gets cancelled, half gets cancelled, MD gets cancelled. Therefore, the value of KH by KD is found to be 10 upon 1, or KH is to KD is equals to 10 is to 1. So, what is the ratio, children? Kinetic energy of the horse is to kinetic energy of the dog is found to be 10 is to 1. So, the correct option is option 1, that is 10 is to 1. So, moving ahead with the next question, children, 13th one. If the mass of a body is reduced to half, mass of the body is reduced to half and its velocity is double, the percentage increase in kinetic energy. This is a different question. You're asked to find out the percentage change. Children, increase means suppose if K1 is the old kinetic energy, K2 is the new kinetic energy. What is the difference in kinetic energy? Final kinetic energy minus initial kinetic energy. But if you want to compare the relative kinetic energy, delta K by old K equals to K2 minus K1 upon K1. This is initial, this is final, this is change in kinetic energy and this is the relative kinetic energy. But as you are asked to find out the percentage change in kinetic energy, you have to multiply this relative energy into 100. Then your answer will be K2 minus K1 upon K1 into 100. This is the formula you have to apply. So, what is the percentage, children? Percentage increase in kinetic energy can be calculated using the formula delta K by K into 100, which is equals to K2 minus K1 upon K1 into 100 is the formula you have to apply. So, let me write the same formula here, children. So, what is that? K delta K by K into 100, which is also equals to K2 minus K1 upon K1 into 100. So, this formula to be taken into granted. As I wrote it there, I am just removing this so that the space can be consumed. So, if the mass of a body is reduced to half and its velocity is doubled, percentage increase. So, first of all, you need to know what is K1. You also need to know what is K2 and then the difference in K2 and K1. So, lot of things we have to solve, children. So, first of all, what is the value of K1? Half M1 V1 square. And what is the value of K2? Half M2 V2 square. That's it. Half M1 K1 square and V1 square and half M2 V2 square. But here, mass of the body is reduced to half. New mass is half of the old mass. So, M2 is equals to half of old mass and velocity is doubled. V2 is equals to 2 times of old velocity. These are the things they have given. Substituting here, you will get the value of K2 as half. M2 must be replaced with M1 by 2. V2 must be replaced with 2V1 whole square. Hence, K2 is equals to half. So, this is M1 by 2 into 2 square is 4V1 square. So, simplifying further, this 2 goes 2 times. Hence, the new value for kinetic energy equals to 2 times of half M1 V1 square. So, K2 is equals to 2 times of half M1 V1 square. It can also be written as what is half M1 V1 square, children? Half M1 V1 square is K1. So, K2 is equals to 2K1. So, if K1 half M V1 square, then K2 is 2 times of half M V1 square. So, relation between K2 and K1 is K2 equals to 2 times of K1. So let us solve the above equation. Therefore, percentage change delta K by K into 100 is equals to K2 minus K1 by K1 into 100, or percentage increase in kinetic energy equals to, what is the value of K2? K2 equals to 2K1, K1 as it is into 100, or delta K by K into 100 is equals to 2K1 minus K1 is K1 upon K1 into 100. So solving this, K1 gets cancelled. Hence, delta K by K into 100. How much are left? 100. So 100%. So what is the value, children? 100%. If the mass is halved and velocity is doubled, then percentage increase in kinetic energy is found to be 100% increased. Earlier, if it was 10 means it will become 20. Earlier it was 100 means now it will become 200. So 100% increased. So 14th one, the kinetic energy of an object is K. Initial kinetic energy was K. If its mass is reduced to half, then its kinetic energy will be speed remaining same. So similar to the previous problem, formula for kinetic energy is kinetic energy equals to half mv1 square. Old first kinetic energy K1 equals to half m1 v1 square, and second kinetic energy half m2 v2 square. But what are the given condition? Mass is reduced to half, but given that mass, I'll just write it here, given that new mass is equals to half of the old mass and V2 is equals to V1, remains same. Okay, that's it. So you're asked to find out the new kinetic energy. Therefore, the new kinetic energy K2 is equals to half of, instead of M2, I have to replace it with M by 2. V2 must be replaced with the same V1. So here half is constant, M is constant, V1 is also constant. Then only number half, this 2 I'll just forward it, half, bringing towards front, then you are left with half m1 and v1 square. What is that? Half m1 v1 square. But what is half m1 v1 square? Is equals to k1, half k1. But that we consider this k1 as first kinetic energy as k1, but they gave the first kinetic energy of the object is K. So instead of K, I have to replace it with K. Instead of K1, I have to replace it with K. Hence, the value is half K. Clearly, we proved that the new kinetic energy equals to half of K. That means K by 2. Hence, third option is true. So, the new kinetic energy is equals to half of the old kinetic energy. So, let us move to the last question, children, 15th one. The kinetic energy of an object is K. What was the initial kinetic energy? K. If its velocity is double, then its kinetic energy will be same as usual. But here, there is no change in mass because the object remains same, so mass remains same. Only changes variable is velocity. So taking the formula for kinetic energy as half mv square, considering the first kinetic energy K1 as half mv1 square and new kinetic energy half m2 v2 square. So as the same object remaining same, so we have no change in mass is observed. So m2 will be remaining as m1, same mass, but velocity v2 is doubled. If its velocity is double of the previous velocity, you are asked to find the kinetic energy. So substituting these values in the above equation, K2 equals to half m2 Okay, I'll just write it once again. Half m2 v2 square k2. So half m2 should be replaced with m1. v2 should be replaced with 2v1 whole square. So simplifying further, you'll be getting it as half m1. 2v1 whole square is 4v1 square. How much is that? 4v1 square. Keeping all the values there and bringing the 4 forward, then you'll be getting 4 times of half m1 v1 square. So what we observed, children? We observed that the value of k2 equals to 4 times of half m1 v1 square. Okay. So therefore, k2 is equals to 4 times of, what is half mv1 square? Half mv1 square is k1 is equals to k1. 4 times of k1. But instead of k1, the initial kinetic energy, they named it as k. So we named it as k1, but they named it as k. Hence, or this k2 can be taken as 4 times of, instead of k1, I can replace it with k. Therefore, the correct option is the new k2 equals to 4 times of the given kinetic energy. So, option 3 must be true. So, with this, we have completed with the numerical part of worksheet number 3, children. So, just keep practicing and let us meet in the next video. Until then, take care.